Alright guys, today we're going to be looking at yet another binary tree problem, and the reason we are looking at yet another binary tree problem is because we want to burn DFS pattern into our memories forever to come. So let's dive right in. So let's go through the problem statement first. Given the root of a tree, write two functions, serialize and deserialize. The serialize function should return a string representing the binary tree, and deserialize function should reconstruct the tree given a string. Okay, so I've kind of tried to define these two methods or these two functions, and kind of tried to give you an example here. So let's look at serialize first. What we mean by serialize. You may have heard of these terms before in other YouTube videos or in the course lectures if you have ever been through them, or you may have heard this if you're already a working professional. Serializing, deserializing binary tree is a very effective way of storing binary trees in memory. So if you have a huge binary tree that was constructed by some other component, let's say in your mobile app or web app, you're using binary trees to I don't know, represent hierarchies or something like that, then you usually serialize it into a string, and then you store that string somewhere in the database, or you shard it or things like that. Now when it comes to using those strings again to effectively reconstruct the original tree, we kind of go with our traditional approach of deserializing the string, and hence the term. Deserializing would mean constructing a binary tree directly from the string, and assuming that the string here that's given to us is a valid string, and that string has nodes, node values separated by comma, and it also has null values. We'll briefly talk about why we particularly need null values in the string given to us. All right, now that we understand serialize and deserialize, let's look at a simple way of looking at a binary tree. Let's say this was our original binary tree. Serializing this would mean just going through the nodes in DFS pattern, and which was going through all the left nodes, which would be the root node's left subtree, and then exhausting the left subtree, and then moving on to the right node. So we first look at left node, we first look at root node, its left nodes and its right nodes, and we kind of call it the post-order traversal. The post-order traversal, which means that we are looking at the root node first, and then we are trying to exhaust all of the left nodes of the root node, and then for each of those we are trying to look at the right node. So if we follow the same pattern, we say this is the root node, we look at 2, we look at 2's left node, which is 3, 3's left node is null. I have tried to represent null nodes as x. So if both of the children, the left and right child of a node is x in our tree, then we know that this is a leaf node, right? So we have looked at 3, now we backtrack to 2, we look at 2's right child, which is again null, we backtrack to 1, we look at 1's right child, which is 6, we look at left child, which is null, right child, which is null. So we know 6 is the leaf node, 3 is the leaf node, 2 is not a leaf node because 2 still has one non-null child, right? So now we know why we need these null values in the list or the string given to us, and the reason is it will be impossible for us to determine if a particular node is a leaf node or not. If we can't determine if a node is a leaf node, then we will never be able to reconstruct our tree if our post-order traversal list or string is given to us. So in this case, it's pretty evident looking at the list that the first node that we are expecting should always be the root node. So in this case, 1 will be the root node. We are easily able to create a node and set it as root node. Then 2 would be the left node of the root node, so we already know it, and we create a new node and set it as the left node of the root node. And then we look at 3, which we know will be the left node of 2, and then at 3 the next 2 nodes are null, so we know that 3's left child is null, and so we have reached the end of the path here. So now we need to backtrack, but before backtracking we need to check the right child of 3, right, which is this last part, and this is also null. So now we know that we have reached a leaf node, so now we need to backtrack, and we go to 2, we say 2's right child is null, and then now we need to backtrack because we have completed our recursive calls so far until 2. We backtrack to 1. 1's right child is 6. And then we spawn up new recursive calls for 6. We say find 6 left node, find 6 right node, and so on. So our DFS call stack would look something like this. We'd have 1 in it, 2 in it, 3 in it, and then we start popping because we have all the null values going forward. And so we pop 3, we look for 2's right value, and then we pop 2, and then we look for 1's right value, which is 6, and then eventually we also pop 6, and then we pop 1 at the very end. So now that we understand what serialize means and what deserialize means, let's just quickly write our code here. I would start off by creating a node class, which would allow us to create new nodes, right? Node, and then it would have a constructor. We could have the value of the node, and the left one and the right one, left node's value, right node's value. Initially, let's have null, assuming this won't be passed to us initially, and this constructor should just do this dot val, which is setting the member variable of the class node val to the incoming val. This dot left should be left, this dot right should be right. And now that we have this, let's look at the second part of the problem. Now this would allow us to initialize nodes, node objects. Now let's also create a class and let's call it tree serializer, right? And that class would again have a constructor, and that constructor would for now, let's say, won't have anything. We'll get back to it if we ever want to add something, but it would obviously have a function, and that function would be serialize, and that would have the root reference to the tree, and then we would also have a function called deserialize, and that would have the string. We can call it s here, right? So we need to fill in these two functions. So let's start filling in the serialize function. So logically, serialize is nothing but a recursive function doing the DFS operation on the given tree, and the tree's root node reference is given to us. Very simple. By now we know how we do DFS, right? So we just assume that this is the first call in our recursive call, and then we also pass in a optional parameter here, and assuming this won't be given to us by the external caller, we can just initialize it to an empty string. So the first thing that we do is say if root, if not root, then we just do a result dot push, and just as we did in our previous example here, we'll use x to denote none or null. So let's just push the x value here, and then let's end the recursive call. So this becomes our base case. Now that we have our exit condition, we just need to go ahead and start creating this string, right? So the first node's value should be appended to the list, right? And my bad, I initialized that as a string. I need to initialize it as a list so that we can do the push operation on it. So result dot push, which is to root dot val, and then now comes the main part. We need to look for left nodes, and the way we do it is by calling serialize again, right? And oh my bad, all right, this constructor should have something for now, so let's just give it a root. now that we have this, we can go ahead and remove these keywords, because, well, in a class we don't use the function keyword, because inherently when we initialize a function with the open parenthesis and close parenthesis, we know that the class knows that it's a function, right? So it's a silly one that we did right there. And right, so we were at the serialized function. We said look for the left nodes. Looking for the left node would mean calling our function and passing in root.left. And then we should not forget to pass along the result array here, and then look for right nodes for all of the corresponding left nodes. So we call this dot serialize again. One more thing to understand is it's always going to be this dot serialize, because we are calling the member function of the class. So we can say root dot right. Let's pass along the result. And once we're done doing this, we're gonna go to the very end and kind of make sure that the result is what we need. There's one other way to do it. We can kind of have the result as the member variable of this class and initialize it to an empty list initially when the constructor is called, right? And the constructor can have the root of the tree, and it could have the string as well, right? We could kind of create a tree serializer object directly and then have these two values. A better approach would be to separate these out. So we have tree serializer as one class and tree deserializer as the second class. So the tree serializer could just have the root passed to it, and then when initializing the object, obviously, and then have the result one initialized to an empty list, and then we can get rid of all of these parameters, because a good function is a function with no parameters at all. And then once we have the root here, we can also get rid of this. Oh, we need this. So this is a recursive function. We need this. All right. So once we call the recursive one here, we have our base condition here, and then we are populating this dot result, not just result. So we can replace this with this, and we don't need to pass this along anymore because we're using the member variable to store it, and we just need to do this dot result. All right. Now, as we mentioned, we would want to separate this out into a deserializer class. So I'm just going to copy this class right here and say tree deserializer, and deserializer again is going to get ns, which would represent the post order traversal string that we need to use to reconstruct this tree. And then we can kind of use yeah, for now we don't need the result. Let's see if we'll need it later on. This will have a main deserialize function. That deserialize is going to get the s. Yeah, this can get the s, or we can leave it as is for now. And we could kind of pass in the nodes here, right? We could say nodes, and then that nodes could and then we could start filling this thing out. Okay, going back to the example, the deserialize was using the list of nodes and then checking if the current node is not null. If it is not null, then we know what we need to do, right? We need to use its value and then construct a new node object using that value, and then eventually setting its right and left children. Okay, so the first thing here to do would be to check. I'm going to initialize a value here. I'm going to say nodes dot value, or in this case I can just say nodes dot next. This would give me the next value in the nodes list, I could just have value assigned to it. Now that I have my val, I'm just going to check if the value in the list is not x, which is if it's not null. So I'm going to check if val is x, then I'm going to end my recursive call right here. And if it is not, then I know that I need to do the same recursive procedure, right? Well, I have my root node, so I first create my root node. The only difference between this one and the other function is, in this case, we don't have a root node, we just have a value. So we first need to create the root node object. So always a best practice to use const when creating objects, or particularly objects that we know are not going to change. So new node, the node class that and then we need to pass in the value, right? The value needs to be integer value, so I'm going to do a %, on the value that we get from the list. And % also takes in 10, which is the radix, right? And then converts a string to an integer. So if we don't pass in anything, it's going to work too. But let's assume that we are passing in the decimal value. Now that we have created this current node, I would want to set the left for it, and then I would want to set the right for it. Okay. This is the node object. Going back to the node class, node object has left and right. So the left child will be calling our deserialize, then passing in nodes, and the right child again would be deserialize, and then passing in the nodes. And we are forgetting one thing, right? The left is calling our own function deserialize on the next node. So we are expecting to return some kind of a node object, right? So the left should be populated with the left new node object. So we have to return the current that we have created using the current value in the node list. And once we have returned it, we are done. So the deserialize concept is pretty straightforward. All we have done is gone through the list and followed a similar recursive procedure, and each time we are performing a additional step of creating the node object, and then doing a left, doing a right population, and then returning the current. Okay, now that we are done with the deserialize method, we are also done with the deserialize class, and then we are also done with the serialize method. Now let's try to see how we can call these, right? So let's say these are our node values, right? And that is something that we need to let's forget about this part for now. I'll come to it in a moment. So let's say this is the list, and we need to first deserialize it and then serialize it, right? So a good way to test this would be to call our deserialize method and pass in these nodes and see if it constructs a tree which consists of all the node objects using our node class right here. And then using that tree, we can pass that tree's root node reference to our serialize method and see if our serialize method works as expected. So if everything works fine, our serialize method that we wrote should return this exact list back to us. If we just pass in the tree root reference that the deserialize method returns us. All right. So one thing to note here is that there's a really cool JavaScript feature that we have used. You must be wondering what root this.nodes.next.value would give us, right? Logically, it looks like it should give us the lists current value, right? So the deserialize function here needs to keep track of the value that we are looking at, right? First we need to look at this value, in the next iteration we need to look at this value, and so on. So we can either keep track of that using an index variable and starting at 0, and then every time in the iteration we can every time we are calling our function, we can pass in an incremented version of it, index plus plus. Or a better way, a neat way, an improved way in JavaScript would be to use the iterable. Now I would like to introduce you to this concept. It's a really nice thing to have in JavaScript, and if you know it, you can just use it. So under the symbol proto object, you have an iterator object, and you can use that iterator object to convert any type of object, be it array, be it a JSON object, into an iterable form. So once you convert it using the symbol.iterator, you should be able to get the next values by just calling dot next on it. So you can look it up once we are done with this question, but all we need to do is make sure that the nodes list that's initialized when this tree deserialized object is created is rather a iterable list. In order to do that, all we need to say is use the symbol.iterator right here. Going back to this one, we are returning a normal list. We instead need an iterator, so when we pass in the normal list here, we can go back to our constructor and say let's convert s to a iterable. Let's call symbol dot iterator, then we call the function on it. All right, this should hopefully work. This should allow us to convert this into an iterable, and then this dot nodes dot next should work going forward. So let's try to run this on our trusty little programmers UI and see what we get back. All right, so I call the deserializer function deserialize, and it should technically return us the root value, the root node object itself, not just the value. So when we try to print the tree root, which I stored in the tree root variable, we should get back the tree root node object. And as you can see, the left part of it contains a list of objects that represent the left node, right node. We can try to verify it. 1 is the root node in our tree, 2 is the left node, 3 is 2's left node, and so on. 3 is the leaf node, and because it's a leaf node, we have the left and right undefined, and so forth. So now that we have our tree generated, we can go ahead and try to test our serialize method in a nifty way. Now that we have tree root, we can just create let serializer equals new tree serializer, and we can pass in tree root. Although this is redundant, you will see why. And then we just need to say we just need to call serializer dot serialize. So we have created the class's object. Once we have the object, we just call serialize on it and pass in the tree root that our deserialize method just returned us. Just the tree root, we are not returning anything else. So now that we have the tree root reference returned passed in, we can just try to print the serializer dot result, because that's where we are storing the serialized list. So you can go back to the class, tree serializer class. We can see that we are storing it in the result member variable, and we should eventually be able to see this once the function is called. Right, the function's called. Now the print should work, and we should see this exact list. Let's try to run it. paste, run. Now this is the output of the deserializer method. This is the output of the serializer method, and as you can see, we got the exact same list back that we passed into the deserializer method. Pretty cool. This works. And this was about it. This was an overview of serializer, deserializer using DFS, and we try to leverage DFS pattern here. Pretty easy concept. Both of these functions, the serialize and deserialize, are basically DFS, but just with additional steps in the deserialize function. And so hope this was helpful. Hope this helps you learn more about DFS. I'll see you in the next one. Until then, happy coding.